Welcome to solverfy.
Fired with initial velocity of 28.5 meters per second at angle of 71 degree, and we have to solve this problem. So let's sketch this trajectory of the flight of the rocket. It will reach some maximum height, and L here is the range of the rocket. So let's introduce x and y axis. So that's y, that's x. Here is angle alpha, and as we can see, the initial velocity has two components, v0x and v0y. v0y is v0 times sine alpha, and v0x is v0 times cosine alpha. Now let's see how vy and vx depend on time. Va decreases with time because there is a gravity force, so it equals to v0 y minus gt, or v0 sine alpha minus gt. But the x is constant because there are no forces in the horizontal plane. So now we have to find h max and total time of flight. So let's start with h max. When the maximum height is achieved, the vertical component of the velocity is 0. So therefore, h max equals to v0y squared over 2g, or it equals to v0 squared sine squared alpha divided by 2g. We can calculate it right away. It equals to 25.8 times sine of 71.0 all squared, and I divided by 2g. Let's calculate this number. It equals to 29.75 meters, which is roughly 29.8 meters. So that's the height of the flight. Now let's calculate time of the flight. So first of all, let's call time of the flight equals to 2 times of reaching the maximum velocity. And again, maximum velocity is achieved when vertical component is 0. So therefore, 0 equals to v0 sine alpha minus gt of h max. Therefore, th max equals to v0 sine alpha over g. And total time of flight equals to 2v0 sine alpha divided by g, or 2 times 25.8 meters per second. Divided by 10 meters per second squared. Let's calculate this number. Oh, sorry, and I forgot sine of 71. Yeah, now we can calculate this number. It equals to 4.88 seconds. So we've solved question B and question A. Now we have to solve question C. Here we have to calculate the range. L equals to V0 times cosine alpha times time of the flight, or it equals to 25.8 meters per second squared times oops, 20, yeah, 25.8 meters per second. Yeah, just times cosine of 71 degree times time of flight, which is 4.88 seconds. So let's calculate this number. It equals to 40.99 meters, which is roughly 41.0 meters. Okay, now we've solved question A, B, and C, and we have to solve question Z, which is asking what other angle could the rocket have been fired at, which would have resulted in the same range. So let's do this. So to solve this problem, we have to show the equation for the range in the generic case. So here L equals to V0 times uh, cosine alpha times time of flight. And time of flight in turns equals to 2V0 sine alpha over G. So therefore it equals to V0 times cosine alpha times 2 V0 sine alpha over G. Let's simplify this function. So it equals to 2 V0 squared over G times sine alpha times cosine alpha. So basically here it means that here we need to find angle beta, which has the same which has the same product of sine alpha and cosine alpha. So basically it means that, okay, let's see what it equals to. So sine alpha times cosine alpha equals to 2g over 2v0 squared, or lg over 2v0 squared, or it equals to 41.0 times 10 divided by 2, 25.8 squared. Let's calculate this number. It equals to 0.308. So now let's presume that there is an angle beta which results in the same product. So sine beta times cosine beta equals to 0.308. And now we have to solve this equation. So for the simplicity, let's Let's replace sine beta with well, honestly, we can actually, yeah, we can solve it in a simpler way. So obviously, instead of solving the equation, what we have to do, we have to use a property of a sine of pi over 2 minus alpha. So sine of pi over 2 minus alpha equals to cosine alpha. And sine of pi over 2 minus beta equals to cosine beta. Sorry, cosine of pi over 2 minus beta equals to sine beta. So that's an important property. So therefore, if alpha equals to let's forget about this numerical part. We don't need it. Yeah, we will do it in a simpler way. We'll basically end up here, and now we will apply these properties. Yeah, if alpha equals to 71.0 degree, then beta equals to 90 degree minus 71 or 90.0 degree minus 71.0 degree. Let's calculate this number. It equals to 19 degree, 19.0 degree. So that's the solution of this problem. This angle beta, which would result in the same range, is 19 degree. So here is the solution of this problem. I hope I helped you. Thank you very much for your attention. Bye.